So far we have seen how we can create monodimensional arrays or unidimensional arrays. We have also created two-dimensional arrays. So actually NumPy provides the possibility of creating arrays that are much more complex, not only in size but also in the structure itself. Such arrays we call it as structured arrays. So structured arrays are a type of arrays which contains structs or records instead of individual items. So let's learn how to create structured arrays. So we can create a simple array of structures as items. For example, like this, we have created here a structured array. Our array, how do you create a structured array is from the NumPy library, you just say np.array and then you can specify all the items. The difference is here each item would be can be of different data type. So as you can see here, the first item in the row is actually an integer, the second item is a string, the third item is a floating point number, the last one is actually a complex number. So that's why we can say that structured arrays are actually arrays that contain structs or records that can represent complex data structures. So let's take a scenario of what kind of structure we want to create. Imagine that we want to store information about different objects. Each object might have properties like it can have a unique ID, the object can have a name, it can have a value, and it can have a complex number. So when you want to store such things, you can easily do this using structured array. So how do you create is just say structure is equal to np.array and define the values of all these different objects. As I said, the first one, let the first number represent the ID, let's say it's an integer. The second one represent the name, which is a string. The third value represents a value which can be a floating point number, and the third one a complex number. So after defining the structured array, you can display it like this. So we have an option called as D type. That's how we are able to create. Because of D type, we are able to store all these different data types. So using D type, you can tell what is the data type of each of these objects. Okay, so after you define the list, put a comma and say D type is equal to, within quotes, right, what is the first data type here? Let's say it's an integer of length 2. So write here I2. The second item, let's say it's a string having characters of up to length 6. So it is represented as A6. The third one is a floating point number. Let's say it can take up to 4 digits. So you write 4F. And the last one is a complex of size 8. So C8. So these are the different data types that you can actually use within your structures. If you want to store bytes, B1. If you want to store integers, depending upon the length, you can have I1, I2, I4, I8. You can also have unsigned integers U1, U2, U4, U8. You can have floating point numbers. Then the data type is F2, F4, F8, and complex numbers C8, C16. And if you want to have strings, then you can write fixed length. Then you can write A of n, where n can be any number. If I write A6, then I can have a string up to 6, characters. So let's see now in the Jupyter Notebook how we can create the structure. So open the Jupyter Notebook. First you have to import the NumPy as NP, and now let's put this structure into a variable called as structured is equal to np dot array. Now within the square, open the parenthesis and close the parenthesis. So within the parenthesis, I'm going to have all the items. So the items have to be put as a list. So let's say I'm using the list. So since it is a list, use square brackets. And now within the square brackets, let me first give the first list. I want to store an integer that is which represents the ID. Let's say I give 1, comma. The next one, the name. The name I'm going to give it as string. Then the third one, let's say I have a floating point number 0.5. Then I have a complex number, let's say 1 plus 2j. So this is our first item. So now let's repeat this. Okay. Now this first item After that, now let's close the parenthesis. Now open the parenthesis, 2 comma, let's say now second is the name. Then give let's give some floating point number, let's give some complex number. Now close the parenthesis. Now open the parenthesis for the third item. Similarly, let's say unique ID 3, then string, then I will write comma, some floating point number, let's say 0.8, then complex number 1 plus 4j. Next, close the parenthesis. Now again open one more parenthesis and close it for the last item. Let's say the ID is, or let's finish off this. Okay, so let's have 4 items in our structure and then close the square brackets. Okay, so remember there will be one square bracket for this one. Okay, here I forgot a parenthesis. So this is our list. See, what I've done here is all these items I am storing it within parenthesis. This will represent each row of the structure. Each row is put within parenthesis, and this entire 3 things are put within square brackets. Now there is one opening bracket here which I will close it at the end, because now I have to specify what is the D type of all these items. So D type is equal to, again, one parenthesis for this. The first one which I have to give within quotes. So the first one, let's say it's an integer of size 2, then the second one is a string of size 6, so A6. The third one is a floating point number of size 4, and the last one is a complex number of size 8. Now you can close the parenthesis for the entire thing. Now execute. Just press Shift Enter, it will execute. So now try to display this. See, this is how our structure has been created. This is the first row, this is the second row of a structure, this is the third row, and these are the data types. As you can see, you may see that the data type of the first one is I2, S6, and then you have a floating point number, and then you have a complex number. Now, if I want to, I can also change these things, right? Suppose I want to change the data types, I can do it. I can do it in the same row. It's possible. Now suppose I want to access individual elements of this, then how do you do it? Just put the index. If I just say structure of 1 and execute, you can see the second row has been displayed. If I say structure of 0, you can see that the first item has been displayed. So you can access individual elements with this. This is called as the index. So first row the index is 0, second row index is 1, third row the index is 2. Okay, so now there's another way of accessing the elements that we call it as F0, F1, F2. See, when I actually displayed this here, you saw that F0, F1, F2, F3 has been created. So what does that mean? There are 2 ways, remember this, there are 2 ways of accessing the individual elements of a structured array. See, first one is through the indexes. If I want to access the first row, as I said, you just put here 0. Structured of 0 and execute. See, I got all the first elements. Or there's one more using the ID called as F0. Each row will have an ID. See, that is already when we displayed the array, we saw that, right? The first one has the ID F0. The first row has the ID F0, second row has the ID F1, third row has the ID F2. So instead of saying F0, I can also say within single quotes F0. Execute. See, but what is the difference is when I say this, it actually gives us what is the data type of it. Okay, so when I say F0, F1, F2, F3, what happens is, using this you can refer to all the elements of the same type. Using this I can refer to all the elements which are of the same type. See, when I said F0, what happened? The first column elements are displayed, 1, 2, 3. See, the first column, because they're of the same type. That is what is shown here. Okay, so the first value or the first column of the array, if you want to access column wise, instead of saying if you want to access the elements which are of the same type, then you have to use this ID F0. See, what has happened is all the items which are of the type I2 is assigned an ID F0. All the items which are of the type string can be accessed using the ID F1. All the items which are of the type floating point can be accessed using the ID F2. And all the items which are of the type complex can be accessed using F3. So did you get this? So the difference here is, if I want to display or access all the elements which are of the same data type, then you can use this F0, F1, F2, F3 concept. When you display the array, you can notice what is that. Okay. See, when I say F0, all the items which are of the type integer are displayed. When I say F1, all the string elements should be displayed. See, first, second, third. When I say F2, okay, yeah, floating point number should be displayed. See, floating point numbers are displayed. When I say F3, complex numbers should be displayed. So did you get the difference? So if you want to access row wise, then just give structured 0 or structured 1, structured 2. If you want to access elements by type, then give F0, F0, F1. Got the difference? Try this. Now coming to the next concept. So now we saw that, right? How to access the elements. We can access the elements using the index. You can access the elements using the unique IDs F0, F1, F2, F3. Now there's another way of also accessing the elements, which we call it as through names, right? We can use meaningful names for the fields in order to increase the readability and understanding. Now how can we do this? Let's consider the same array. Go back to the Jupyter Notebook. Let's clear these things. So to clear the row, just click on that row and click on this scissor button. That is a trimming button. You can clear the row. So now let's consider this structured array here, right? So now what you can do is add an array. To add a row, just click on this plus button here. So what I will do is I will give meaningful names. Right? So far what I did, I use either the index 0, 1, 2, 3 or I use the unique ID F0, F1, F2, F3. But that was not very meaningful. So instead we can give meaningful array to make it more readable. So how do you do it? Just type here structure dot dtype dot name. So that means what? To the data type I am going to specify some external name equal to, open and close the parenthesis. Now give the names within quotes. So what is the first name I want to give? The first one I said, the first item in our row indicates the ID. So let's give it as ID. Then what does the next element indicate? The next element actually indicates the, let's say, first, second, third. So something like an order it is indicating. Next, comma. The third one is actually representing the value. So give the value. And the third one is a complex number. So just give complex here. Okay, so what we have done here is we are giving meaningful names to each item in our list, and just say shift enter. So you can just display this. So when you display, this is what we gave now. Now how do you access the elements? So instead of saying structured 0 or structured F0, now I will say structure of ID within square bracket, single quotes. See, when I said ID, all the elements 1, 2, 3 got displayed. So next, let me say order. That is our second element in the list. Okay. See, now you can see first, second, third got displayed. Now let's say structured of value. And next structured of complex. Okay, so that's it. So just quickly revise to what we have learned in today's session is what are structured arrays, They are different from unidimensional and two-dimensional arrays, because these structured arrays can be used when you want to have arrays that contain structs or records which can represent complex data structures. We saw how we can create a structured array with different data types. Next, we saw how we can access the elements of the array. We can access the elements of the array using the index, or you can access them using these unique IDs F0, F1, F2, F3, or we can give meaningful names. Right? We can give meaningful names like this. We can say the dtype structure.dtype.names, give meaningful name to this and access the elements using the meaningful names. So try this in your system. Try to create different kinds of structured arrays. This is a very important concept. It definitely will be very useful when we are working with very complex and very huge database. Thank you.